Today here with me is Mike Schuster. Mike is managing director at 2 Sigma, where he heads up the AI core team. 2 Sigma is a New York City-based hedge fund managing a portfolio worth $58 billion. Before 2 Sigma, Mike was at Google Brain, where he led speech recognition and later machine translation. In fact, he led the effort that brought neural nets to Google, transforming the way their translation system works. At 2 Sigma, Mike is using AI to help a hedge fund use machine learning to develop machine learning, neural networks, deep learning, and AI technology for financial products. So happy to have you here with me. Welcome, Mike.
Hey, Peter. Very nice to be here.
So, Mike, I'm going to dive in with a quote from 2 Sigma from when you started there. There was an article in Dealbreaker announcing when you joined that Mike Schuster has the chance to be the hedge fund's last human employee. What do you think about that quote these days, a couple years after the fact? Are you the last?
This sounds like a great quote. It's funny to hear that, right? Because a couple of years ago, I heard a lot of hype around AI and neural networks, and not just for finance, but like everywhere, right? Mm-hmm. And in fact, I have a bet with somebody who you know pretty well too, that I made that bet in 2017 at NeurIPS, and he bet with me that in 10 years Google will not employ people anymore. And I'm not going to reveal who it is, but it's somebody you know well. And I was surprised to hear that. And this kind of incredible expectations, I think, is what drives finance maybe a little bit as well, and AI in finance. And I think the truth is there's, of course, some of it is used, but it's not nearly like this, right? So we can talk more about it here on the podcast, but we have regular jobs and we do the best we can, basically. And that's how it looks like.
So has somebody been hired since you've been hired at 2 Sigma?
Oh, of course, lots of people. I mean, we've hired, in fact, how you introduced me, I mean, is maybe not, it sounded a little bit too nice, I would say. I mean, there were lots of other people who did a lot of work. It's not just me, right? And in fact, that's, I think, a very important topic, a very important point, that nobody by himself can really do a lot, right? Whether it's in self-driving cars or in speech recognition or translation or finance, it's always, in almost all cases, a relatively large group of people with a lot of technology to make things work.
Right.
And that's the same for finance, by the way.
So you have a whole team, of course, working on things now. What topics we've covered in the past here have been how AI can do all kinds of things, often with physical robots. But your position at 2 Sigma, it's a very different thing AI is doing. It's I think maybe one way to think of it is AI is trying to make money. Would that be a great description of what the AI is trying to do?
AI is helping to make money. That is maybe the right way to say that. And I would say in a similar way, like in most technology companies, right? I mean, if you take a Google ad system or a Facebook ad system, there is what others would probably call a lot of AI also at work. And similar to that, I would say it is in a place like 2 Sigma. There's lots of data, lots of noisy data, lots of complicated technology and systems, and we just have to stick it all together and develop the right metrics to improve. But eventually, there is, of course, I mean, our goal is to make money, to not lose money. That is also a very important goal, and to to basically play in this financial system. And there are many, many different ways of doing that, right? So Two Sigma is not calling itself actually a hedge fund. It's a financial science company. And it's a similar thing. The hedge fund is part of it, but there's a lot more. There's a real estate arm. There's an insurance arm. There is Two Sigma Ventures. There is market making. There's all kinds of different things, and all of these parts need complicated technology, and in some case, learning from data, meaning learning what a lot of people today call AI, to just make better decisions. And that's really what our group initially was supposed to focus on, to help all other groups in the company with their complex technical problems that maybe need things like neural networks or potentially reinforcement learning and some other complex topics like that. So
I'm trying to imagine. I've never worked at a hedge fund, so I mean, I'm just trying to, or a investment science fund and so forth. And I'm just trying to imagine what's happening there. I got to imagine there's a lot of people thinking really hard about, what are the right decisions to make to try to make profits, but also balance risk and so forth. And I'm just wondering, where is the AI? How is the AI jumping into this process? I
try to explain it to people often with a different example. Let's say you are at Google and you look at the ad system, right? A lot of people are familiar with the ad system. There's lots of users out there, and they click on it, and it's in that way very similar. It's a very complex system that, for example, risk. I mean, what does risk even mean, right? Risk is how much money is involved, or risk is how much money you can lose in a day. There are many different definitions of that, and they probably even differ between the different groups or different financial companies. But eventually, it is really about predicting the future in a certain time span, right? So in a certain horizon, you can say, do we want to predict it tomorrow, or do we want to predict it next week or next year, right? And all these will, or maybe next second, right? It's that depends a little bit on what you exactly are doing, but that's a big part of it. Now, when I think about the AI predicting things for the future, I mean, as just really a layman in the investment space, of course, what I look at is things like stock trading, right? Should I buy or sell this stock? Is that a reasonable way to think as one of the prediction problems that matters, is predicting where the stock will be next hour, next second? I don't know. For example, yes, that's exactly right. And as you can imagine, this is a very noisy process and very difficult because there is a lot of competition, and it's a lot more difficult than I would say most people imagine. Is my guess. I definitely think it's difficult. If I knew how to do it perfectly, I might not be chatting with you right now, but just being actively trading instead. I'm not so sure about that. I mean, a lot of I think this comes down to the fact what our jobs look like, right? And our jobs, we try to be scientists, right? We try not to be traders or something similar to that, and this depends a little bit on the company. I think in our case, in Two Sigma's case, it's especially that we have a culture of nice geeks, I say, and we try to be scientists and try to look at the problem in a scientific way, and that is what motivates us, right? It's of course a lot more fun when it works, but that's true for every scientific problem. So in the sense that I know that you're working on, in a way, similar problems, maybe not in the finance space, but on similar problems. And that is what motivates you. And this is the same for us, right?
Mm-hmm.
And as you know, my background is also maybe similar to yours, because I've worked long in tech and so.
Absolutely. So when I think about this, I'm just thinking about, these stocks going up and down. And if I just think about, okay, how am I going to think about that? If I make a decision for my own finances, I might think of things like, okay, well, maybe I think this company is going to do well for this or this other reason, or better than other companies for this or that other reason. Maybe, they've been hiring some great people, and I think that'll make them do better. Or maybe, I like their latest product that they put out. But when I think about that at the same time, I'm just like, wow, I use so little information to make those decisions. And I'm just thinking about the, AI. I mean, AI can today's AI keep up with all the news that comes out every day and read it all? What's the ballpark there?
So first of all, I would challenge your assumption a little bit that you use only very little information, right? You think you are only using very little information. But I believe in many cases, when you make a decision to buy or sell something, you actually have maybe spend weeks or months or years hearing about the company, and things that matter, right? Now assume you could do this for all companies in America or all companies in the world, right? That's of course what you can't do as a human. But in your particular case, when you have a certain company in mind, the few that you do have in mind, you probably know something about, right? And so maybe your decision is actually not that bad as a human, right? So, and about your question, I think that's a big part of it, that let's first use all the information that is there. And there's a lot of information, obviously, right? There are everyday prices, there's volume, there are news out there, there are satellite pictures, there is the weather, there is international politics, and so on, right? Tons of information that could potentially be used. Now the question is how to use it. And I would say, in a hype way, you can say AI is helping with all that, but in another way, you can say, well, good engineering and building complex systems is helping with that, which is more a traditional way of looking at it and maybe framing it. And I would say there's not that much difference, really.
That's so interesting that you mentioned all these sources of data. If these sources of data can be used to make informed financial decisions, then if you take it a step further, you could also think that a lot of value is in that original data, and whether people are able to collect it or not, and bring it together in the right place to get it processed, and choosing what data even to collect. Because there's probably still more data than you can process, even with today's biggest computers. And it seems like there might still be a lot of human decisions there.
That's exactly right. Just imagine, let's say, news as one source, right? I don't know how many news sources there are every day just in the US, but now you multiply that by the number of countries, there's certainly a lot. It would be nice to be able to process that all at the same time, but as we know, the people who have built practical systems, is that it's very hard to build even a simple system that does something useful. And so we try to focus first on, building a simple system that does something, and then, add more bells and whistles to it to make maybe use of, let's say, more news channels or, different types of, satellite pictures. I'm just, some of these examples, I'm not even sure about whether we in particular work on these, but they could certainly be examples.
Now, a lot of the things you bring up are text resources. And your work in machine learning for text didn't start at 2 Sigma. In fact, you have a long history. Maybe that's why part of why they hired you. So I'd love to ask you a few questions about that. So as I understand it, you actually grew up in Germany. Is that right?
I grew up in Germany, yes.
And from there, you went through this journey, landed you in Japan, Germany, US, and in the process, you discovered neural networks. Can you say a little bit about how do you run across neural networks as a thing you wanted to study?
Right. So, I grew up in Germany and was always interested in science and music and arts and stuff like that. Was not very interested in languages actually at the time. And so I studied EE, electrical engineering in Germany. There was no computer science at the time when I studied. And then after my master's, I went for a year to Japan and wanted to do something different. In the first half year I spent there, lived with a family, learned language, some of the language. Then I went to Tokyo and actually worked there with fiber optics, which was, very high frequency physics, basically. And then I came back and wanted to do a PhD in Germany with a professor that had me introduced to this simulation of antennas using Maxwell equations and things like that, which was similar to the fiber optics that I had been working on. So I, for some weird reason that I forgot the exact details, but there was they had a change in students or something, student numbers that year, and I couldn't work with that specific professor, so I started with somebody else. And this professor that I had, that in fact the other professor had chosen for me, the group turned out to be not that great. They weren't that scientific. So at the time, I said, okay, I want to do something else. And there was this other professor who had just come from Japan, and he was working on speech recognition with neural networks. And language was something that I found always interesting. And I said, okay, I'm going to quit this PhD. I'm not going to do it. I'm going to work for free with this other professor. And that's what I started doing. And I just learned neural networks basically by myself, right? At the time, this was early. There were some books, but not many. I started reading them. I started programming. I knew how to program because I'd done it for a long time, but programming neural networks, and just learned with that small group that he had there. And within a few months, I had the chance to visit Japan again. And my professor said, why don't you go to NTT and ATR and visit them? NTT is the biggest telecom in Japan. ATR was a big research lab for what we call today AI. They did speech recognition and translation and neural networks and all kinds of things with about 300 researchers. And so I visited them and I asked them, so can I work here? And they said, no, you don't have a PhD, you can't work here. So I went back home. And then a month later, I got an email from them. Well, we have reconsidered, maybe you can work here. And it turned out they were giving me a job. And I was actually really happy about that because I didn't have a job at the time. And so I went to Japan again and started working with them. And after 6 months, they said, why don't you stay here and do your PhD here? And that basically was my 4.5 years that I stayed at ATR in Japan, where I basically learned everything about speech recognition and neural networks. And that really was the start of this journey in a way. And it was great because this research lab had a lot of funding and a lot of really was a great atmosphere. Lots of international people would come from all countries. And I was a researcher who could just write papers, and I got a small salary. I mean, so I could live. And that was at the time really my dream, and it turned out really well, I think.
Definitely, I would say it turned out well, everything you've achieved since. Kind of curious, at the time, I mean, you went, from Germany all the way to Japan. It's quite a distance away from home.
Right.
Because you had this opportunity to work on neural networks. Was it, were there people working on neural networks in Germany at the time, or was it just this time where people just mostly ignored it, except for some few labs that you found in Japan?
Right. It was about maybe I started reading about neural networks in the early 90s. And, that was a time when it was, I believe, this already the second wave of neural networks. Mm-hmm. And there were definitely some success stories at the time. I know that, for example, for phoneme recognition, which means you speak into a microphone, there's a system that just transcribes what phoneme you said, not what words, right? But just phonemes. So it's a lot less. It's a lot easier to do that than words. There was a very good system at the time that actually used neural networks. So, and that motivated me. I said, hey, this is such a great way of doing it. We should put more research into this, right? And it was actually kind of interesting because every speech conference I went to, it was the same group of people from around the world, around, 10, 20 of us or so, who worked on neural networks, but nobody else was. It was really an interesting time, right?
That's so interesting. It sounds like roughly a parallel to Jan LeCun was working on neural networks more so in computer vision with not many other people at that time. And you're on this parallel journey in the speech recognition world where there's only a small group of you working on neural networks at that time.
At that time. That's definitely true. Yes. I didn't know Jan LeCun personally, but I knew of his papers, and we went to similar conferences and things like that. But it was interesting. A big conference which today has many thousands of people, which we called NIPS at the time, is now NeurIPS. It was I think I went there in 1999 or 2000. There were maybe 100 people there total.
Oh, wow!
And half of them were came from the biological side and not from the machine learning side. So it was kind of an interesting world in comparison today.
Yeah, very, very, very different. Wow. Now you get your PhD in Japan.
Right.
What happens next?
Right. So I first stayed for another half year or so, or almost a year, at this research lab. And this was the end of, so I got my PhD the beginning of 1999. And 1999 was the year of the boom here in the US, right? So it was 99, 2000. There was a lot of hype in tech. So, and of course, that was very interesting to me, right? I go like, wow, this sounds like such a great world to be. And I said, I want to go to the US. So, and I applied at the time, to 5 or 6 different companies, and chose to go to Nuance, which was at the time a small speech recognition company with about 200 people. Had been founded 3 years before. And I joined them in late 1999 and was then here for the whole ride through the boom and bust era, which was actually quite interesting in Silicon Valley, right? It's I think a lot of people today would be interested in how different it was, because we haven't.
I'm curious, how did you experience that?
Well, initially, I didn't really know much about how business works or anything at the time, and I came here and lived in a house in Silicon Valley somewhere with my family, right? And it was a lot of everything tech was suddenly not interesting anymore, right? And there were lots of people who made a lot of money on stocks, but most people like me who had just come from somewhere else were just like really looking at the whole situation. For me personally, we had a 6 months lockout, which was very typical at the time, so we couldn't really sell anything. And also, I didn't really believe that stocks can go down, right, at the time. To me, this was all new, and I go like, oh yeah, this is just a temporary blip. But it turned out to be not a temporary blip, and it just went down and down and down. And I remember my time at Nuance, the peak was something like, was it $199 or something like that? $180, right, was the peak from an IPO price of, I believe, $17 was, and then it went down to 50 within a few months. And at the same time, the company started, there was a layoff every 6 months of 20% of the company. And that was an interesting time when suddenly there was no more Coke in the fridge. And, today everybody has like a mini kitchen and things like that. At the time, Coke in the fridge was maybe all we got. And suddenly the Coke in the fridge wasn't there anymore because the company didn't have the money to pay for it. So it was a kind of, I think, a rough time for many people, actually, especially in 2002, 2003. And by 2003, we were somehow fed up with this. And my wife also wanted to go back to Japan. So that's what we did.
Oh, so you went back.
We went back. What
did you go back for? Where did you go for?
Yeah, so we decided, okay, let's go back to Japan. I got a job at NTT, which is a big telecom with about 300,000 people, as what they called at the time a research specialist, which is just a research scientist, I guess, and to work on speech recognition. And that's what I did in a great lab on the border of Kyoto and Nara in Japan, in Kansai. And it was a great lab. We wrote a lot of papers, did a lot of research, but because it was a big company, everything, a big Japanese company, a very traditional company, everything was kind of, I would say, slow. And actually, what is another interesting part was that at the time, speech recognition was something that had almost died. So speech recognition was very interesting in 2000 and shortly after, but by 2005, there was almost nobody who wanted to work on speech recognition anymore.
Why is that?
Because it did not have the amount of success that people thought it could have, I think. A lot of the companies, including Nuance, made a lot of promises that didn't really pan out at the time, I guess, and so people decided speech was too complicated. It would never really work well enough to help people. And while I was at NTT in Japan, I was there for 2.5 years. Some friends from Google called me in late 2000 or mid 2005 or so and said, "Hey, we are forming a speech group. Do you want to come back to the US?" And I said, "Well, let's think about it." And so, but eventually, we decided to do that. And Google had a small speech group, built a small speech group at the time, actually with some of the founders of Nuance, which was kind of interesting. So we were 10 or 12 people from all around the world, and it was a great small team. And we started doing it again, right? And so that was really the start of speech recognition at Google. And I was in that group for many, many years until end of 2012, I believe. And we did lots of things. We collected all the data, built all the technology. And it started out with we put it on an iPhone and then on an Android phone. And we had a different system before that, which was called Book 411, which was just over normal telephone. But yeah, so eventually, a lot of people today maybe can't really imagine this, but it was a almost shocking technology that people said, wow, on a smartphone, you can talk to a smartphone, it can actually recognize what you say. That was something so new, especially in other countries.
As you were working on this, I'm curious because you said there was disillusionment. People abandoned speech recognition as an effort around, you said around maybe 2005, a lot less effort in it. But Google decided we're going to do it anyway. What was your sense at the time? Is this feasible?
I always believed in it, that it would work somehow, right? But I think a big problem was how to make a business out of it, right? How to make it useful enough such that you can pay, for all the development and all the technology that you need to make speech an important enough thing. And that is actually true for many other technologies that are hard to, in a way, monetize directly, right? And one of them is, for example, translation. You can say, hey, obviously translation is useful, but how do you actually make money out of it? I think that's a difficult thing that many people have asked themselves, and they go like, well, even if it can work, if it's not part of a big company, we can't really afford this, right?
Talking about translation, after you worked on speech recognition at Google, you transitioned into machine translation there. And there is the big New York Times article in 2016 called The Great AI Awakening. And it's actually largely about the new Google translation system that was coming into production at that time. Can you say a bit more about what happened there?
Right. So when I started working with the brain team, which was different from the speech team, I wanted to work on something else, right? Because I had done speech recognition so long, about 15 years or more at the time, that I said, and I had seen everything so many times that I said, hey, I would just want to work on something else. And translation was something that I was personally always interested in because, I had spent a lot of time learning some Japanese, right? I obviously spent some time learning English and some other languages. And to me, that was a very interesting topic. It's also very similar to speech recognition in the sense that you map a sequence of things onto another sequence of things, meaning a sequence of words in one language onto another sequence of words in a different language. And that is similar to speech recognition. And in fact, to some other technologies as well. And this is how I got into this. And initially, my PhD was actually about sequential models of that type as well. And so it was something I was always interested in. And I go like, okay, let's try out a lot of things. And I think for a year or two, I tried out a lot of things by myself in the brain team. And most of it was just too complicated to be feasible and good enough. But then we had this other group of people. We had a lot of interesting people in the brain team who came up with this new idea of sequence-to-sequence models. What we know today as sequence-to-sequence models, which was really a very simple way of dealing with this problem. And there were some papers end of 2014 that showed that this could work on small databases for translation. And the first thing what we did then, me and actually two friends from Google, we got together and said, okay, first of all, we need to duplicate these results. Now, that took a long time to be able to even duplicate them. And then we said, okay, now we need to apply this to like bigger databases. And a lot of people, including the people in the translation team at Google, they said, this is impossible. We have billions of sentences. You can't. There's no way you can do this. But with a lot of work in solving, every problem that we had, after quite a while, we got this running. And I think we used 96 GPUs at the time, and it took like 2 weeks to train and things like that. And eventually, we built a system that was, in the first language we tried was English, French. And I still remember the head of the translate team told me, you cannot improve this much. We have improved this for 10 years. There's no headroom, right? And the initial result we got was already so much better than what they ever had. Wow. So basically, there were many details involved, but the improvements we made with that new system, with that new technology, were about as big as the previous 10 years combined at Google on all these languages. And what that meant for us was that many of the languages that were really bad before, like, for example, translation from Korean or Japanese or Russian or something like that, suddenly improved to a level that was actually useful, right? And that was it. So the real impact was that many language pairs went from not working to working, and that really made a big difference. So this was not, of course, not just me and my friends, right? We had help from a lot of people in the brain team, plus very quickly the whole translation team, in fact. So my guess is there were at least 20 to 30, maybe 50 people involved in this whole effort to get all that done.
I'm really intrigued by this notion that even on the first attempt that you did, it was already better than the existing system. What was that moment like when you saw the first result?
I mean, we couldn't believe it ourselves first, right? So we had an idea that it would be much better, but what was actually interesting, and this is maybe something that people who have worked on complicated technology also, is that it's sometimes very hard to even evaluate whether something is good or not, because it's actually quite complicated to calculate a number, right? Mm-hmm. So in a number that measures, let's say, accuracy or something like that. So we had a system there for the translation system where we said, okay, this is our data. We use some training data. We reserve some test data, and then we test it on the test data. Okay, so. Which sounds like a normal way of dealing with this for any machine learning system, but that's not how the translation team was actually measuring performance. So what they did was they had, I think, 5,000 sentences from 10 years ago, which they translated into every language. And they were using those 5,000 sentences as their like holy grail for measuring performance, measuring accuracy. And this is, of course, a little different than just picking the same distribution as what you have from your training data. So if you already have a test set that is decided and is from a completely different distribution, then maybe you don't get as good results, right? And that is, we eventually got much better results on this specific test set that they had as well. But these are the kind of problems we had to solve and basically get around to even convince them that this is working at the time. But this was a long time ago, right? I'm sure many of these things are solved right now.
Now you have the big success with machine translation at Google. And then at some point, you decide to go to 2 Sigma. How did that even come about? Like, I mean, you're working at Google, which is kind of the tech world. 2 Sigma is the finance world. like how do you even cross paths with the
Right.
people from Two Sigma and decide that this is the thing you want to do?
Right. So I found finance always intriguing since in fact my PhD days, right? So I always thought, wow, this is very interesting. How can this even be done, right? So there was always this world out there that I didn't know anything about, and in fact, I spent a lot of time, private time, vacation time, on writing a system that does some of that. And I learned by myself a lot of what to do and what not to do. For example, how to get data, how noisy is the data, what are some useful models, how do you even think about a model, and so on. And I had, I would say, a pretty nice system that that took many years to write, and that was running, on my machine at home. But the thing was that I had just not enough time, right? I had I have a family. I had a job. I had many things to do, and it was just not enough time. And at some point, I go like, "Wow, it would be so nice to do this with other people." And maybe have what happens if you already get data, which is actually in a nice format, and you don't have to collect it yourself, and so on, right? And so I was always interested in this. And what happened in, I think, 2017 or so, people contacted me via email and all kinds of things. And eventually, usually I never answer these emails, but I said, I was on vacation and just wrote back to one guy, hey, this is a nicely written email. And, we talked then for a while. And by chance, I met the previous CTO of Two Sigma, Alfred Spector, who used to work at Google. I met him at Google outside, just walking around, and we chatted for a while. And he said, "Hey, why don't you come to Two Sigma and give a talk about translation?" And I gave a talk about translation. And he had me talk to a whole bunch of other people, and then they apparently decided, "Hey, we want to hire you." And that was kind of shocking at the time, because I had actually decided I wanted to go to Japan with Google to help building a brain team presence there, which I then didn't do. And I said, you know what? This sounds really like the chance that I wanted, that I can work with other people on finance in a place that, where it's their job to do these things, right? And I said, okay, let's do this. It was a big risk for me personally, because also I had never lived in New York and I didn't know that much about it, but it turned out to be great. I mean, I think we're on the right track, and there are lots of interesting things. And in fact, the work is very similar to, I would say, is what the brain team was originally, right? Meaning half the people work on actual applications to make things work right now. The other half working on more longer term research, what will happen in finance in the next 3 to 5 years or so. And there's lots of interesting stuff that we work on, and maybe we can talk about some of it if you're interested.
Yeah, I want to learn a lot more about that. Actually, first, I'm curious about this thing you just said about you're running some models on your home computer.
Yes.
What does that mean to be running some models? Can you make that a bit more concrete?
I mean, what I did at home was you get some prices from somewhere, let's say from the internet, right? And you get them every day, and you train some models, meaning you predict what is the price going to be tomorrow of something, right? And then you do that every day, and you see whether that actually can generate a positive return or not, right? If you would actually make these trades, right? And I think this is what probably a lot of people are trying, right? And it's I guess it's quite hard, and it's getting harder every day to make that work. But that's what that means, right?
When you say it's getting harder, when you say it's getting harder every day, why is it getting harder every day? Why is that?
It's similar to, well, there's more competition is my basic guess why it's getting harder, right? People, maybe what used to be a linear model 30 years ago is now a more complicated model, and not every effect in the world is linear. And with a nonlinear model, you can maybe get better results. And now people have been doing that, right? So, and the question now is, how complex do you make these models, and what kind of effects actually go in there to still make it work, right? And this is what a lot of the finance industry is trying to do.
Now, when you started, that's not when finance started using machine learning. Machine learning has been part of finance for a while, if I understand that right. What are some of the initial uses of machine learning in finance?
So, I mean, of course, you know that I only started there in 2018, right? So I don't know much of what happened before, but as far as I understand, I've read a lot of books about it, and machine learning in the classical sense, let's say linear models, for example, or and even a lot more complicated models, right, have been part of finance for probably 30 years, if not more. It's, some people call it time series prediction, right? So how do you predict a price of Apple tomorrow when you have the last 5 years of Apple prices, right? One way to do that is you could say tomorrow is the average of the last 5 years, right? That would be a very simple model, probably wrong, but also maybe not that bad, right?
Now, I got to imagine deep learning changed things quite a bit in finance compared to the previous machine learning methods. Is that something you've seen happen, where deep learning is now a core thing? Or do you think more traditional models are still useful?
I don't know what others are doing, right? I mean, this is one problem in the finance industry, that there's not really a lot of scientific literature that you can look up, and everybody wants to write papers about what is the latest best thing, right? Which is more what happens in tech, I guess. In finance, you don't see that so often, for the obvious reason that you don't want to publish this. But my feeling is that there are at least some areas where deep learning has helped. I would, and as an example, maybe news is a good example. I mean, how do you extract any information out of news without a neural network in some way, right? There are now very, complex models that are talked about in the tech world, like BERT or stuff like that, which help to extract information in a better way, right? So, but I would say everywhere where you used a simpler model before, like you calculate an average or you have a linear model or something like that, once you make it non-linear, it could be a neural network, right? And then that could work, but whether it does work or not really depends on the particular case, and it's not like automatic that everything works, right? Not at all. In fact, a lot of things, in fact, don't work.
Yeah, I mean, certainly to get neural nets working still takes a lot of effort in pretty much every domain.
Right.
Now, I'm kind of curious, when you think about the role of machine learning, and probably a lot of it neural network training and so forth, in finance, and the role of humans, because there's also human traders, right? And how do you see, like, where do you see the neural networks make more decisions or play a bigger role in decisions versus where do you see humans play a bigger role?
So the way I see the finance world today is it's so broad, and there's so many things to trade, and so many effects to look at. The first, I would say, is the area where you do have a lot of data, right? Enough data to have meaningful training and test sets, for example. And that, you could, for example, let's say real estate. Okay, how do you estimate the price of a house? Can you get the data? Can you do a better? Can you build a better model with a neural network? Maybe, right? But in real estate is maybe a not such a great field for this, because actually you may not have enough data, right? While for, let's say, some if you want to make very quick trading decisions, what happens in the next second, as an example, there are many seconds in a year. So within a year, you can get a lot of data that maybe helps you to have a training and test set here, right? So longer term effects are more difficult because you have less data. Shorter term effects are easier for the opposite reason.
I hear these stories about trading firms wanting to be as close as possible to Wall Street, and having very fast internet connections to execute on trades really, really fast. Right. I got to wonder how this influences neural nets, because neural net, it seems like if you're going to want to be on this fiber cable to make a decision, then it seems more so than maybe any other application that may have neural nets, you want to have neural nets that can process things really, really fast. I'm curious about that part.
So speed is obviously important, but speed is not the only thing, right? So you can always probably trade off speed against intelligence, basically, or ability of the system that you have. If you know for sure, let's say, what is happening in a week, it's much better to know that than to know for sure what's happening in a second, right? And the reason is because you can put a lot more money behind it, basically, right? So the question is what you should really focus on, right? There are many people who focus on the second, but the week may also be pretty useful, I guess.
But then you'll have less data, right? If you have to do in a week interval predictions, so then all of a sudden your machine learning problem becomes harder. Less data.
That's right. Then you have less data, and everything becomes more difficult, right? And that's the problem that I guess a lot of people are dealing with, right? A week is maybe also a pretty long period, I'd say, right? I was just making an example, but you could have a day as an example, right? What will happen tomorrow?
We are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. So then it sounds like maybe when you went from Google to Two Sigma, not too much changed culturally, but are there maybe still some things that are culturally different?
So people ask me that a lot, right? They say, okay, so you came from Google to Two Sigma, what is the biggest change? And I would say that the biggest change is for me is that it's a much smaller company. That's number one, right? Google had, when I left, had over 100,000 people. Today, 140,000 people or so. Two Sigma is 1,500. And that means that we are almost all in New York, meaning when you have been there for a few months, you have seen every face in a way, right? You may not know every person, but you have seen every face. And but the second bigger difference is that overall, at least compared to what I was used to at Google, people are maybe a little bit more traditional and a little bit more towards they have this sense of, oh, we need to do everything exactly right, which may have something to do with either West Coast, East Coast difference, or potentially, but also with just the field we work with. Because if we make, we cannot, again, the comparison to speech recognition, we cannot push out a speech recognizer that is 5% worse for just a while, just to look whether it works on something like that, right? We don't want to do that, right? Because that would potentially cost a lot of money. So we need to be just very careful with this. And I think this thinking to be very particular about everything you do and checking and rechecking and checking again is an important part of this, which I personally, I think actually that's quite nice. I don't want our customers to find bugs, for example, right? This is not what we want to put out there.
Now, what you just covered is the kind of work, the way people work. I'm curious, more superficially, does everybody come to work in a suit at 2 Sigma?
Oh, no. So people look more or less the same as in Silicon Valley, maybe not as loose, but that's probably more an East Coast, West Coast thing. We come to work at normal hours, I'm usually there at 9. I leave at 7 or so. I mean, when we were still in the office, right? But now we are not in the office, so it's a little bit different. But people just wear normal clothes. We hire from the same universities, mostly very good ones. Many, in fact, especially the people for our team are. They have to make that choice. Do I want to go into finance or do I want to go to a tech company? So this is often what happens actually with the candidates that we get.
So saying the recruiting is in direct competition. The same kind of candidates are considered both places.
That's right. Which makes it really interesting, right? This used to be something that has also changed in tech, I think, a lot. For example, 15 years ago, if you wanted to work in speech recognition, it was very good if you had some experience in speech recognition, and this was the only field you would work in. You would not work in translation if you did speech recognition, right? Today, that's totally different. If you know speech recognition, of course you can work in translation because it's almost the same technology, right? It's similar in finance. It has become more technical, such that there is more overlap between tech and finance, and we've had some candidates, for example, who went to Tesla instead of coming to us. So you go like, wow, okay, interesting, and their job may be very similar to the job they had done with us, right?
Under the hood, at least in AI machine learning, a lot of it is becoming unified across all fields very quickly.
That's exactly, I think, where, in a way, the world is definitely going in finance, right? In tech, I've seen this in a bunch of areas. First in image recognition, then partially in speech recognition, then in translation, then with the games, with AlphaGo and things like that. And I think similar things are probably already happening in finance already, right? There will be more complex models and more complex systems. It will become more and more important to really be dealing with complex interfaces and complex systems all together in somebody's head. And that is the skill that is needed. And of course, understanding all the machine learning literature, as well at the same time, and all the algorithms and what else is out there, and having experience with these kinds of systems. And that kind of knowledge is what we need, and in fact, what I think tech often needs as well.
Now, talk about experience that's needed. You said machine learning experience, and that's at the core of it. Are there certain topics in finance that are good for candidates to know about, and what are good ways for them to learn about them?
I don't think there's actually anything in particular that people should try to learn preemptively, in a way, right? What is way more important is, at least for our group, which is very engineering heavy, can you, for example, set up a distributed machine learning neural network model in the cloud and have it trained, which has thousands, 10,000s, maybe millions of parameters, right? Have you done stuff like this before? That's a very typical experience that many people have. I would say that the finance part most of it can be learned relatively quickly, and you learn that on the job, right? On the fly. So I'm not saying it's not important. It's just that the other part is something that takes very long to learn. Let's say how to program properly in Python or C++, how to do unit tests, how to do integration tests, how to make things fast, using a debugger, using a profiler, and all these things, right? Then the very finance specific knowledge is often also not on our level, really, right? We are more on the somewhat prediction level. We don't deal with the interfaces that exactly are on the market with all the exchanges or things like that. We don't deal with that stuff. We have a whole team that does that, and they try to simplify it such that we can use it in a better way, right? Or the rest of the company can use it.
So, Mike, I have some friends who work in finance, and when I walk in to their office back, when people were going to offices and so forth, I'm sure I'll be back soon. But when I would walk into their office, what I see is they sit at a desk. And this desk has programmers have a lot of computer screens, but these traders, they have even more computer screens. So there is something like an array of 6 or even 12 displays in front of them.
Right.
And there's all kind of numbers and graphs going there. And I mean, how can a person keep track of all that? I got to imagine that that's the kind of thing an AI should be better, should be able to see everything at the same time. Of course, it still needs to make the right decision, but it seems really hard as a person to process so much information.
Of course. And that is, again, this has, I wouldn't call this AI, I would just call this technology, right? This is exactly what the automation has brought over the last 30 years, right? That we can look at many stocks, many commodities in all countries at the same time, and can make decisions based on that, right? That's exactly right. So, by the way, your friends are probably not programmers or scientists in that sense. They're probably closer to a trading desk or something like that, because Correct. I can tell you that in our case, our desks do not look like that, right? Our desks look like a desk at Google or Facebook, where you have maybe 2 monitors and you have code running on it, and you just program basically and run experiments.
Now, one thing I found really intriguing is that, I mean, as you've alluded to, the finance industry keeps things pretty close to the vest because it's competitive. You don't want to give away your secrets, right?
Right.
But Two Sigma actually put several competitions onto Kaggle over the past few years, including using news to predict stock movements, rental listing inquiries, and a financial modeling challenge. And so I'm curious if you were involved at all in those, putting those competitions out, and how do you think about these?
So I was not involved in them. In fact, I found out about 2 of them because you told me, which is kind of interesting. I mean, Two Sigma is a pretty big company, right? 1,500 people right now, and there's lots of stuff that I just have never heard of. But in general, I think that's a great idea, of course, right? I mean, how did, for example, there was a Netflix challenge in 2011 or so, or maybe it was even earlier, 2000. Maybe it was way earlier than that. But I remember that, right? Because I worked on it as well to predict what movie to watch based on your history of movies. And this was a great success for Netflix at the time. So in the same way, if you put these competitions out and you have a lot of people look at it and they just come up with different ideas and you reward them in some way, that's a great way to share the technology and also to maybe get some results, right? So it's great if companies do that.
And the specific one I'm most curious about, of course, in the context of this conversation, is the one that says using news to predict stock movements, because that's text processing. So can you say a bit more? How could an AI be trained for something like that?
So actually, this may come as a surprise to you, but although I have worked a lot with texts in the past, I'm actually not working with text right now. This is not our group. There's a different group at Two Sigma that does that. But let's just hypothetically, I actually do not know what they are working on, right? I know that they're working with news, but that's about it. But hypothetically, can you get a sentiment out of a news article, right? So meaning you read an article and say, okay, this article is positive or negative about whatever company they're talking about. So you need to figure out what company they're talking about, and you need to figure out whether it's positive or negative. Just these 2 things are, of course, noisy, right? So as an example, let's say it's about Whole Foods. Now, Whole Foods was bought by Amazon. So now how does that influence the original Whole Foods stock, and now it will influence the Amazon stock, right? But if you look now back in the data, you need to understand that at some point Whole Foods was actually a separate stock and then was bought by Amazon. Your system needs to know that. And the second thing is then, of course, how to evaluate exactly the sentiment. So is this better than what people thought? That's often a thing that matters in finance. Or is it worse than what people thought before? That's very hard to decide. So it's incredibly noisy and hard to actually get some useful information out of this. But still, it is done a lot. I mean, maybe not this particular example, but people look at all kinds of data to try to find out, if something can be learned.
It's very hard to get that signal out, but statistically speaking, if you even get a little bit of signal out and you average it sufficiently often, if you're always a little bit better than average, then this will add up, I imagine, right?
This can add up, but this can take a very long time, right? And this comes back to the data problem that is maybe a little bit different than in tech. So for example, in speech recognition or translation, if we wanted to test a system, what we do is we just collect more data and collect a test set and then test it on the test set. And we collect so much data that we are sure about the statistical properties of it. And we just run this new system and we go like, okay, it's 5% better, we're done, fine. Now, in finance, there's only one day at a time, right? If you need another year of data, you need to wait a year, right? Or the other thing you can do is you can reserve some part of the past for this, right? Which is hard. And so it's actually very hard to make decisions that are where you can see this is clearly a better result, right? Which is much easier in tech because basically the amount of data is infinite. While, I always give this example about Apple. There's only one day of new Apple price a day, and that's it, right? Even if you have 20 years of the past, and that makes it very difficult.
So interesting is you've said before, what's so different about tech versus finance is that the data in finance is both too much and not enough. And what you just highlighted really alludes to the not enough. And so I'm curious about the too much. When is the data, there's just too much data?
Well, too much data it is when you, let's say you want to predict all prices of all stocks in the US, let's say, right? I mean, I don't even know how many stocks there are, but they're probably 10,000 or more, right? So now you have the problem, you have to get historic data for 10,000s of stocks, and it needs to be correct, right? It cannot be just, somebody made up that data or something. It needs to be what actually happened at the time. And what you'll find is that a lot of data is just has holes in it. There was a trading stop that you didn't know about. Somebody maybe fat fingered a trade, and the price became temporarily 10 times as high. Is that real or not, or is that because the reporting software was wrong? The different sources of data are often not entirely reliable, right? And this is so the amount of data that you can get, which is often in a horrible format and just in many cases wrong. That is what I mean by too much data, right? Now you can also go to even smaller timescales. Let's say for stocks, for example, there are many different exchanges, and they each have their own slightly different data. There are also rules about that, but there's price data, there's volume data, there's book data, right? So meaning how much at each time point, how much data there is at the bid and ask and above and below that, right? So this is what is called the book data. There is so much data that it's very hard to select the right thing, right?
Now, there's so much data, and the other thing I've heard you allude to is that the signal to noise ratio on the data can be challenging. How does that compare to, let's say, speech recognition? And what makes it be noisy in finance compared to, let's say, speech?
Right. So I actually hear that a lot from finance people. They always tell me, finance is so difficult because the signal to noise ratio is so low. And on a you can say that sounds true, right? Yes, there is not a lot of signal. But I always tell people that if you compare the difficulty of improving a state-of-the-art speech recognition system at a large company, or improving the translation system or vision system at a large company like Google or Facebook or any of those, I would say it's of similar difficulty as improving a trading system at a large company like Two Sigma. So the difficulty is kind of similar. So signal to noise, it depends on how you measure that exactly, right? And usually most people who just say that don't have a definition of measurement in their head, right? They go like, okay, there is not much signal. So, but one thing, one example I often also give people is one big difference is that from tech and between tech and finance is that in tech, let's say you build a speech recognizer and your speech recognizer works 95% of the time. And then a different company builds it and it works 96% of the time. So you can use both of these speech recognizers. Yes, one will be a little bit better than the other. In finance, the difference is that one is 1% better than the other, right? That is what matters. So meaning one is 0.5% below the mean, the other one is 0.5% above the mean. And this competitive nature makes it, I mean, I guess that is what competition is, right? It makes it much more likely to use the one that, of course, gains money instead of the one that loses money. I mean, in practice, it's not really like 100% like this, but the competition is just a much bigger problem in finance than in tech for speech recognition or any of those technologies.
Right, and I think that's pretty fundamentally different there, right? Because when you build a speech system, I like the analogy there. You build a speech system, if it's really good, the relative to another really good system is only a small influence on the user experience in most cases.
Right.
In finance, this notion that if you're performing below average, even if you're making very precise predictions, you're actually likely to lose money. It makes it completely unusable, in fact.
Right.
Which is so interesting. It seems like it would drive things forward more quickly. I mean, it seems like it puts a lot more pressure on everyone to keep improving quickly so you don't fall below the mean.
That's right. You need, I mean, it's very similar, I would say, in tech, right? You continuously need to improve your systems such that you don't lose out against other big companies. And in finance, it's the same thing. And this is why Two Sigma in particular, I think, has focused on, this AI and new technology, which we believe will change a lot of things and is maybe already changing things. And this means not just to have, not just to say you want to do it, but also to find the right people. That takes a lot of time, right? To find the right people. You need to interview hundreds of people to find a few. You need to come up with a plan that is actually feasible in a way, right? And I think we are every day we're thinking about that. What could we change a little bit today that makes the things in 3 years better, right? And that is actually not as obvious as it sounds. It's you can work on so many different things, and I find that for us, not everything works. Of course not, right? We try things out, and I always tell my team, part of the research here, part of the research experience is not only do we have to solve the research problem, part of the problem is to define what the problem is. And that is, I think, often true for many other new research areas as well. I mean, as an example, reinforcement learning, for example, which is partially we work on that, is where do you even start? What is your goal, right? And you find many different possible ways through your maze of research, and you basically need to adjust every day to hopefully make the right decision for tomorrow and next week and next month.
Yeah, I think it's always one of the biggest challenges in research is to decide what to even work on, what has potential for a breakthrough. Now, one thing that I'm really curious about is there's a lot at stake with the systems you build. I mean, a lot of money at stake, literally, right?
Right.
And so how do you think about I know when students, let's say, go intern at a tech company, they often will come back, school year, and they'll be like, I wrote code that went into production, and that's, things went into production and people are using it. What's the process like at a place like Two Sigma, when you write code, come up with a new machine learning model, and want to bring it into production. And it's got to be somehow more stressful, I imagine, in some ways.
It's I don't think it's actually that different from a tech company. So again, I'm trying to, when you compare it to the Google Ads system or Facebook Ads system, right? It's a big system. There's obviously a process. There are many engineers that take care of the process and how a new part of it is actually productionized, right? And we have that too. So if you have something that looks great, it's actually very hard to make to make a useful addition, I'd say, especially if you said an intern, right? And an intern probably will not have enough time to do stuff like that, right? But let's say a new employee, and this could take a year to add a useful part to the system and to understand at all how to add something to the system. And then, there's lots of people involved, there's process, there's not just one number to look at, but maybe 15 numbers that need to be in a certain range before it actually makes sense to add something. So, but this is very similar, I'd say, to technology companies.
If I think about applications in finance, right? The simplest one to think about for me is just which direction is the stock going to move? Is it going to go up or down, and how much? Is it going to go up or down? I think a lot of people know about that, have tried that themselves. They just, try to trade some stocks and try to predict up or down based on some information they have. What are some other applications that especially AI can play a role in finance?
So some of the things that we do, we try to help all groups of Two Sigma. And for example, we had one part of the system that let's say takes 200 milliseconds to calculate. And we said, okay, can we approximate this exact calculation with a neural network? So how do we do that? Okay, well, we collect some data from the real system. We train a neural network. And then we just replace the forward pass by whatever the system did before. And it turned out we could do this. So yes, we lost a little bit of the accuracy that the system had before, but we could do it 10 times as fast in 20 milliseconds. Okay. So, and this is a really typical part for us that, is definitely useful to do, because it speeds up part of the system. And let's say that part of the system is run, 10 million times a year, and that is a lot of hours, right? So, and then it becomes actually real compute money. And this is in a way just new technology, but this would be a typical example. Another maybe example is what is an outlier, right? You could say, okay, you could look at prices of stocks and say everything above a certain mean, let's say you assume it's a Gaussian distribution. You say, okay, one standard deviation, if it goes above that, is an outlier, right? Or two, let's say two standard deviations. Okay, that's one way of doing it, but is that really the best way, right? There are probably better ways of doing this that somehow use more information than just the average of, let's say, the last year, right? You could make this time dependent. You could make this depend on more features and things like that. And then you maybe get a more useful prediction of what an outlier is, which could help you in all kinds of other parts of the system. So this is another example that we've been thinking about of how to add that somewhere and actually improve, transparency of the system.
It's interesting because those are examples where it's not directly making a decision for a trade or price prediction. It's actually looking at an existing part of the process and bringing in machine learning to make that part of the process faster or more precise than it was before.
Right. In fact, what you said before, making a decision for a trade, that is almost never done. It's always part of a bigger system, and we are somehow trying to solve or improve a little part of it.
When I think about in the extreme case, though, which sounds like we're not there today, and probably that's a good thing, but if I think about reinforcement learning, I could have a reinforcement learning agent which just optimizes reward, which just optimizes dollars in the account, I guess.
Mm-hmm.
And if it's somehow that reinforcement learning agent is really, really good, hopefully quickly without losing much money in the learning process, then that agent would actually be trading, right?
That could potentially happen at some point, but so there are a couple of things that are complicated about this. Of course, the technology itself is complicated, right?
Mm-hmm.
The second thing is that risk, whatever you call risk, meaning how much money do you lose at the most. Mm-hmm. So usually the general consensus is the more risk you take, the more reward you can make, right? This is probably true in normal life, but also in finance, right? The problem with this is, though, that once you hit zero, you're done, right? So that kind of risk you do not want to take, and that is the thing. They call it the black swan event, or maybe the pandemic, right? We hear now every day about certain financial companies blowing up because of some weird effect that maybe had to do with the pandemic, right? And so this is what you have to avoid at all costs, and that's a difficult thing to do, to get right. A third problem with things like reinforcement learning, and in fact many complex technologies, is that there's a lot of regulation in finance, and as enforced by the SEC or the CFTC or some other bodies, depending on the country and what is traded and so on. And they have certain views of what can actually be run and what cannot be run. And if they don't have, you have to have a certain explanation for certain things. And if you cannot produce that explanation, then you cannot do it this way. So they will simply forbid it. And I don't know exactly what all the rules are, but there are many, many rules in different parts of finance. And this is basically a hard problem to get around, right? It's challenging, but it's also for the safety of everybody, right? We don't want and don't need systems that in the worst case hit these black swan events and then lose a lot of money, right? This is not good for individual investors, not good for the companies, not good for the system. So that's why this exists.
I mean, it's definitely a big challenge in current AI systems to be explainable and transparent. A lot of work still has to happen.
I mean, I always compared a little bit, self-driving cars is maybe a good example as well. You, in general, they're doing great, but you want to avoid the very small probability, unrealistic cases that maybe you have not seen during your training time, because maybe a human would not have made that decision, which eventually leads to some kind of accident or something. I think it's a very similar, way of thinking about this.
Through this conversation here, I get a sense that your team is actually a lot more like a tech team than maybe what we see in movies about finance, like Wolf of Wall Street kind of movie. Not representative of your life.
No. So this is maybe a great question because it comes down to what kind of expectations people have, right? And maybe social media is partly to blame for this too. That it's so much easier to get all kinds of crazy information that may not be true. But one thing that I've seen a lot is that people come in, although they know that finance is not like the Wolf of Wall Street. Maybe it used to be 40 years ago or whatever, or 30 years ago when that was. But people still have that somewhere in their heads. They think it must be a little bit like that, right? But I can guarantee you this could not be further from the truth, right? It's at least where we are, it's really more like a boring tech company, people interested in solving scientific problems. And I personally think this is the right approach, right? So, another Billions is maybe another series that, I've just watched a little bit of that. There may be places that work like Billions, but I actually doubt it, right? I mean, I wouldn't know. It's not like that in our company at all.
Curious about that, because you're talking about your team, the AI core team, and then other teams also doing machine learning.
Right.
But if you look at Two Sigma as a whole, what do you see in terms of kind of machine learning? It's like 50% of the people are into machine learning, or is it even more?
We are trying to figure that out ourselves, actually. I would guess we have hundreds of people working on machine learning out of the 1,500. But the question is, of course, how much, right? What do you exactly define as machine learning? And I would say, what is machine learning to me? It's, okay, if you use Python with sklearn, if you use TensorFlow, if you use PyTorch, if you build neural network models for whatever, if you build, I don't know, tree models or whatever is out there, right? Then you are working on machine learning. And overall, I would say it's about that many people. But then there's of course, engineers as well, who, you cannot really completely separate the AI research scientist from a regular software engineer. Right. In fact, in our group, specifically in my group, it's a spectrum, right? Some people work more on the research side, others work more on the engineering side and making toolkits and interfaces and tests and documentation and all that stuff. But everything is necessary eventually to make things work.
Now, you're thinking about your team and beyond, kind of if you try to envision how finance is going to change due to artificial intelligence becoming more capable in the next 5 to 10 years, what are some things that you think will be really different from today?
It's very hard to say to make really accurate predictions, right? But one thing that I think will happen is that you will have more complex systems and models. And by that, I mean, you have more parameters in your models that will be trained by using some kind of learning from data system. This could be as simple as, the things that we know, like maximum likelihood, or how do you sequentially make decisions in the best way to achieve a final goal, like we do this in reinforcement learning. So these kind of technologies are moving into the field. That's at least what I think will happen. If you ask some other people, I know that at some other finance companies, they have actually killed the machine learning teams. They have just got rid of them, right? And well, you wonder, okay, what happened there? I don't know what happened there, right? Maybe they couldn't produce anything that makes sense, or maybe the hype was too big. Maybe I don't know. There was just not enough money, and I have no idea, right? But I know that it's a questionable thing. It's not entirely. Not everybody believes what I believe, and people are also very skeptical, right? This may be partially because of the hype. That you say, okay, now there's a system like AlphaGo, or we can do everything with machine learning, right? And suddenly everybody around you expects that everything will change because of machine learning suddenly, right? Which is of course not the case. But what is also not the case is that nothing will change. So it's somewhere in the middle is going to be probably the right operating point, I'd say, for the belief. And while a lot of people point out problems with machine learning systems, it's undeniable that it has made a huge amount of progress every day that we use every day, and people just keep forgetting about it, right? There's speech recognition on your phone. There's translation on your phone. Your photos get sorted and tagged. I mean, this is all machine learning eventually, and that is all, not all, but many of the things are actually quite useful.
Right. So if I'm interpreting a little bit what you're saying here, it sounds like your vision is that it's not like machine learning will come in and completely 0-1 change something. It's more that there are these complex systems that are being used in finance, and various components of these systems can be improved. And you're seeing a shift where gradually more components are amenable to improvement through machine learning, and the system as a whole becomes more capable as a consequence. And it might be something that kind of it's like it's slowly happening, and it's not a step change, but it is becoming more and more prevalent in the next 5 to 10 years in your vision.
That's correct, exactly.
Now, as you work on, go ahead.
It may sound to some people scary, but it's not really scary, because this is what has happened in technology over 100 years, right? If you would have told somebody 100 years ago that you will have a small machine in your hand, you can type in a few numbers and you can add up those numbers, and the result is going to be there immediately. And when I'm talking about a calculator, right? People would have said, you must be crazy. This cannot exist, right? And now for us, it's a complete normal experience. And I think we keep forgetting how things change, and how normal many of these experiences can be. And I think that will be similar in finance as well, right? I mean, help people to invest their money better, for example, in a certain way, right? How many people make big mistakes with how they invest their money, right? Well, you could say they're risky, but in some cases, they're certainly mistakes, right? And if you can somehow have a system that helps them with that, well, okay, maybe on average, things will actually get better for people.
Now, Mike, it must be the case. I mean, you worked on so many projects that are all, they're very, very hard projects. I cannot imagine that everything worked on first attempt. Iteration required. What are some things that you personally do to keep yourself sane when things don't work right away, and excited about what you're working on?
In my personal case, I've always tried. I'm trying to do things right. So I don't give up that easily on if there's a certain hard problem and I believe in it. If the motivation is still there, if the problem hasn't completely changed, I will keep working on it. And this is what I tell my group too. I go like, guys, you will not have a success every day. As long as we're making progress and the motivation is still there, let's keep doing what we're doing, right? Or in some cases, a new problem comes along that is maybe even more interesting or more more predictive for the future, right? Then we'll work on that. But what I do personally is, so don't give up. That's certainly one thing. I try to keep thinking sometimes about things that are really far in the future, right? What happens in 3 or 5 years instead of what happens next week? And I think that you don't want to do this all the time, right? But once in a while, you need to step back and go like, okay, what will happen far out? Because eventually that is really what matters, right? What happens next week? There's only so much you can do in a week, and there's not that much difference, but you need to have this goal that is bigger and can only be achieved in, let's say, 3 to 5 years. But I'm not saying 30 to 50 years, because, in 30 to 50 years, I don't know what's going to happen. Some other things that I do personally is to not, I need to have other things going on in my life. I personally do a lot of sports, endurance stuff. And I'm trying to always view things with, do I have, I call this scientific common sense. And lots of things that we work on require to look at things from a different angle. And how do you get into that state of mind to be able to look at things from a different angle? And there are many ways of doing that, right? You can, actually, in my personal case, I often try to make jokes about it in some way, right? Because with a joke, you look at it in a different way. And while it sounds, you actually laugh about it, and that may help, but this puts you into a state of being able to look at it differently as well. So it's about being more efficient, actually, right? I think that is just something that I try to do all the time, right? We need to have fun, right? This is it's not just a job, it's something that I'm really interested in. And of course there are boring days, right? And lots of things that don't work out, but eventually you can say, hey, once in a while something does work out, and those days are really the ones that matter then. And maybe, one thing, just because I think this also goes into because it's so funny, is many years ago when Charlie Munger came to Google and somebody asked him about the imposter syndrome, what to do about it. He said, and I don't think even it's his quote, but he said it. He said, nobody is useless. You can always serve as a bad example. And, and I just thought this is a great way of just saying this, and not just because it's funny, right? It's also, it points out that even a bad example can give information, right? Which we exactly know. Without negative examples, you don't learn. It's very important to have those, and in life, and also, but with all the technology that we use, right? But anyway, so these are just a few things that I do. For me personally, the sports is actually a big part that if I don't do something every day, I go crazy, basically.
So let's see, Mike, this was a fantastic conversation. Learned so much. Thank you so much for joining us here. Thank you.